All attendees on today's webinar are on mute, so please submit your questions via the question function as shown here. And we will cover those during the Q&A at the end of the presentations. And since we have multiple speakers today, please indicate who your question is for when submitting your questions. With that, I'd like to introduce Sunita Satyapal. She is the Director of the Fuel Cell Technology Office within the Office of Energy Efficiency and Renewable Energy at the U.S. Department of Energy. Sunita.
Thank you, Amit. And first of all, I would like to thank all of the participants and those calling in. As you know, we're doing this second webinar across continents, and so we realize it's 5 a.m. in California, 10 p.m. in Japan, and of course we have Europe. So once again, thank you for all the interest. We received significant feedback that the first webinar was a success, and so we'd like to continue this. So today we'll be hearing from the participants and leaders of the second International Workshop on Hydrogen Infrastructure and Transportation that was held on May 8th and 9th, 2014. We'd like to thank the host again of the workshop. It was held at Toyota Motor Sales Corporate Accessory Center in Torrance, California. There were over 70 international experts in attendance, and the workshop was designed really as a follow-on to the first workshop that was held in Berlin. We'd like to thank our German colleagues in June of 2013. And the meeting, the goal was to identify challenges, potential solutions, share best practices and progress on the key issues facing hydrogen fueling infrastructure and fuel cell vehicles. And again, we'd like to thank the European Commission, Germany, Scandinavia, Japan, and of course the U.S. colleagues. And as I think many know, the recent announcements by the major car companies on fuel cell vehicles available for lease and soon for purchase have really increased the sense of urgency from the state, local, and federal government agencies. And so the workshop was focused on key areas: hydrogen fueling protocols, metering, quality, station hardware, and included experts from industry, international governments, national labs, from a number of international regions. They gave presentations and then identified the challenges, the progress, and through breakout sessions. And so given the fact that there was limited space at these types of hands-on workshops, the purpose of the webinar is to report the key findings and, in the spirit of openness and transparency, to share the information from the workshop. And so it is now my pleasure to introduce the first speaker, who will be Dr. Kiyoshi Yoshizumi-san, the director of the Fuel Cell and Hydrogen Technology Group from NATO in Japan. So I'll turn it over now to Yoshizumi-san. Thank you.
Go ahead.
Thank you all of you. My name is Kiyoshi Yoshizumi, and I am not doctor. And I am in charge of R&D project on hydrogen utilization at NATO. First, I'd like to thank you for your participation and contribution to this webinar. Here in Japan, we are having very exciting moment now. As you know, Toyota started to sell Mirai, and several companies also started hydrogen retail sales at hydrogen refueling stations. So FCVs and hydrogen are at commercial stage. Still, we need more R&D on HRS in terms of cost and reliability. NATO continues to promote R&D to address these issues. Therefore, I think this webinar is very valuable for discussion and information exchange among experts and engineers from leading countries and regions. NATO will support such R&D, and I hope our activities will also contribute to this webinar to move it forward. Again, I thank you all, and I'm glad to join this webinar. Thank you.
Thank you very much. This is Erica Sutherland now speaking, and I am a Technology Development Manager here at the Department of Energy. I will be taking us through the overviews for each region which was participating during the workshop. Hanno Busch from NOW was kind enough to organize this webinar this time around, but unfortunately he is unable to speak today, but he is on the line in case we have a specific question. Starting with the overview that we received from the European Commission. So the Joint Research Center of the European Commission and the Fuel Cell and Hydrogen Joint Undertaking began the overviews during our meeting, noting that the following were seen as significant barriers to hydrogen and fuel cell technology in their region, which was the high retail cost of vehicles, lack of infrastructure, and low level of consumer acceptance. The Alternative Fueling Infrastructure Task is working across the European Union toward common technical specifications for the infrastructure, and the AFI, as a joint dialogue between the EC, the European Council, and the European Parliament, and is in the final stages of approval. Article 5 of that AFI addresses hydrogen. It requires that the member states adopt hydrogen infrastructure and must build an acceptable network with cross-border links by the end of 2025. A major challenge is that the SAE J2601 2014 document cannot be referenced to a European legal document. They must refer instead to an ISO or TS 20100 gaseous hydrogen fueling technical specification, and the hydrogen purity standard ISO 14687-2 and the connector standards. The TC 197 group is also working toward a less restrictive and hopefully therefore less expensive purity standard. Between the 3 FCHJU activities, H2 Moves, HITEC, and Swarm, 149 FCVs and 6 stations will be deployed through 2016. Additionally, 46 buses and 8 bus stations will be deployed in the same time frame. They are specifically working on 3 issues related to this workshop: legal metering of hydrogen, electrochemical compression, and fueling protocols for temperature controls during fast fills. The FCHJU is also involved in hydrogen safety sensors, safety analysis of leaks, and collection of safety incident data. For Germany, Hanno Busch of NOW delivered the update. The National Innovation Program for Hydrogen Fuel Cell Technology provides 700 million euros from 2006 through 2016 for funding in the area of transportation, hydrogen production, industrial applications, residential cogeneration, special markets, cross-cutting issues, and innovative drive systems. The Clean Power for Transport Directive of the European Commission was once again mentioned, which is the same directive as the AFI presented by Pietro Moretto for the European Commission. With regard to the development of the hydrogen refueling infrastructure, there are the 50 hydrogen refueling station program of the Clean Energy Partnership, a now project of the NOW, was presented. The aim is to establish an initial hydrogen refueling station network of 50 stations throughout Germany by 2015. Currently, there are already 12 in operation, and 6 will be operational by the end of April 2015. 16 more locations are contractually fixed, and there are 20 that are in the final planning and negotiation phase. Also, there are 6 H2 Mobility members that are developing a joint venture to achieve a maximum of 90 kilometers between each hydrogen refueling station on the highways, and with 10 hydrogen refueling stations in each metropolitan area. They're spending roughly 350 million euros to deploy the 400 hydrogen refueling stations by 2023. The joint venture is in negotiation for the total funding amount. And Given the need for permitting stations, a guideline for approval of the hydrogen refueling stations has produced a website and a booklet for applicants and authorities to follow to deploy the hydrogen refueling stations. Efforts are also underway to develop an aligned European hydrogen infrastructure development plan. Once permits have been obtained, current delivery times for the stations could be between 9 to 12 months, depending on the manufacturer providing the equipment. For Scandinavia, the overview was given by Bjorn Simonsson of Hynor. The Scandinavian Highway Hydrogen Partnership was established in 2006 and includes member countries of Norway, Denmark, and Sweden in collaboration with Iceland. They have a target to have 300 stations and 200,000 fuel cell electric vehicles on the road by 2025. One advantage in the region is that the ZEV vehicle purchases are exempt from the registration tax, which can be 100 to 180% through this region. Also, they have greater than 400 million euro, which have been spent on R&D and hydrogen fuel cell technologies to date. By 2016, 19 hydrogen refueling stations are expected in operation. This includes 7 in Norway, 11 in Denmark, and 1 in Sweden. In Norway, all hydrogen is 100% renewable, and funding is not provided for entities using natural gas to produce hydrogen. On-site production of hydrogen via electrolysis is the most viable form of hydrogen production in Norway, and the market for ZEV vehicles is growing quickly. In 2013, roughly 8% of all new cars sold were already zero electric vehicles, and this is projected to reach 15% soon. All right. For Japan, you've already heard much of the activities there, but they recently released their Strategic Energy Plan, which identifies hydrogen as a very important secondary source of energy, and its production, transportation, storage, and utilization will all be promoted by the government. They have funding of 7.2 billion yen from the Ministry of Economy, Trade, and Industry, METI, in 2014 for station development. They also supply R&D funding of 3.25 billion yen through NIDO. In terms of hydrogen refueling infrastructure, by 2015, the end of 2015, there will already be 100 stations in place. 41 are decided at present, and at the end of February, 9 are already operating commercially. In Japan, R&D focuses on regulation, standards, infrastructure, and hardware reliability and safety. One example would be the success of a demonstration project in 2014, which is now being used to complete the commercial installations. And finally, for the U.S., we have several activities and policies in place, particularly in California. We recently have an 8-state MOU which puts into a zero-emission vehicle action plan to put 3.3 million zero-emission vehicles on the road by 2025. And in California, there's a ZEV program in place intended to put 1.5 million zero-emission vehicles on the road in California by 2025. We also have an activity, H2USA, which is a public-private partnership focused on advancing hydrogen infrastructure. And it's organized to overcome the hurdles and barriers to deploying hydrogen refueling infrastructure in the U.S. and is organized into 4 working groups tackling specific challenges, including station hardware, station location, market acceleration, investing, and finance. The Fuel Cell Technology Office has also opened the H-Prize, which is available, it's a prize of $1 million to be awarded to the developer of the home and community refueling technology, which best meets the criteria posted and available on the website. The criteria relate to pressure, dispensing time, refuels per day, availability, and cost. The Fuel Cell Technology Office has also established the Hydrogen Fueling Infrastructure Research and Station Technology Project, H2FIRST, which is led by Sandia and National Lab and NREL National Lab, which will focus on station qualification, dispenser components research, and reference stations design. Within the U.S., there's approximately $135 million per year in funding for fuel cell R&D through the Department of Energy, with an additional $60 million per year of funding for fuel cell technology deployments through other agencies. And California recently announced $20 million a year from the California Energy Commission to build 100 stations in California through 2020. Current status: by 2016, 51 stations are planned for California, 8 are currently open, and 43 are in development. Additional activities are now underway in the Northeast. With that, I will turn things over to the technical portion of our talk, starting with Mr. Jesse Schneider from BMW North America. He is the leader of their codes and standards development. Jesse?
Hi, good morning, good afternoon. This is Jesse Schneider. Yes, thank you very much for the opportunity to speak. I thought it was a very interesting workshop. And regarding hydrogen fueling, one thing that was new at the time of the workshop was the release, or I should say the publication, of actually 2 standards, SAE J2601, which standardizes the hydrogen fueling protocol, and SAE J2799, which standardizes the communications to assist in that fueling protocol. That was something that's very good in the fuel cell vehicle world, to be able to commercialize hydrogen, to have a consistent fueling protocol worldwide for all fuel cell vehicles. The ability to fuel all fuel cell vehicles between 3 to 5 minutes for fuel cell vehicles or light-duty fuel cell vehicles with a 2 to 10 kilogram onboard storage range is something that's been given through 2601. It uses a standard lookup table-based approach with new features for robustness. And in addition, it has been validated not only in the laboratory, but actually with field in 3 countries, actually 3 continents, in Japan, in the United States, and in Europe. It also gives allowance for communications and non-communications, and just to simply state, the communications gives a higher SOC, but you still can get between 90 and 100% with non-communications, and 95 to 100% with communications. There's also an appendix for a non-normative alternative fueling method called the MC method, which has the potential to increase fueling time and also decrease the cooling energy. And I just want to mention, as it is correct, the Alternative Fuels Directive cannot directly reference a SAE standard. However, there are many those from the SAE team that are actually on the new group, which is called 1980-1, which is going to replace 2100 ISO standard for gaseous hydrogen fueling stations. And there's an effort underway to harmonize and reference 2601 through that ISO norm or standard. And if we can move on to the next slide. Thank you. There was a lot of workshop members from across the world and in these 3 continent regions. But what was really interesting was that the challenges are pretty international. They were pretty much, I wouldn't say the same, but they were very similar in the regions. The 4 top challenges is lack of a procedure and equipped method and equipment to certify station performance, meaning the fueling validation of SAE 2601-2014. There also is a lack of metering technology able to meet the weights and measures accuracy for legal sale of hydrogen. Interesting enough, it's pretty much the same worldwide. Lack of standard acceptance criteria, and there is a high cost of fueling validation. So to address this, I'm just going to list shortly the points that came out of the workshop. This is the results of the discussions, and at the end there was I think a really good result and a path forward, a plan forward. So there's a effort to create a device to verify station performance for each market, a so-called station testing apparatus for fueling. There's also a development need, so to speak, for test procedures and goals to certify stations. I know CSA is working on something, and ISO is working on some as a validation procedure as well. There's also a need to actually have third-party testers for certification, like natural gas or gasoline, and define frequency requirements for certification and work within 19880-1, the ISO document. So regarding metering technology, there's really a need for the government and the industry to work together to enable more accurate and affordable mass flow meters. And the goal is 1 to 2% full-scale accuracy, which is important, and that's something that is underway right now. There's also a lack of, regarding the station standard acceptance. It's important, especially to assist in permitting, that lessons learned are recorded. It's also important to consolidate requirements in the form of a checklist with the input from the automakers and the stakeholders involved in approving stations and also in the standardization effort in ISO. Training and information is needed to help for the implementation of 2601, and also preparation for requirements on how to implement the alternative method of the NC method, which is currently being worked on at SAE Fuel Cell Committee. So regarding cost of validation, it's important that there's developed combined hydrogen station testing apparatus for one-step station acceptance, for metering, quality, hydrogen quality sampling, I should say, fueling protocol, and modification, essentially, of a fuel cell vehicle storage tanks for performance of testing. There's also governments have issued RFQs or requests for funding to find reasonably priced devices, and that's something underway in the United States with the H2 First. They have what's called a high-step device. In Germany, the Clean Energy Partnership has a device, and in Japan, there's a device that worked on also at HISUT. And then the last point here is to consider type testing at the time of station manufacturing.
Thank you very much. Next, speaking to the quality, fuel quality work, will be Andres Fernandez Duran. He is the leader of hydrogen energy activities at Air Liquide Advanced Technologies. Andreas? Andreas, I believe you may still be on mute. All right. Let's move to metering, and then we'll see if we can get Andreas back.
Sure.
For metering, Dr. Will James, who's our Safety Codes and Standards lead here at the Fuel Cell Technologies office at the Department of Energy, will be covering our activities. Go ahead.
So, thank you, Erica. So it's a pleasure to be with everyone on the phone. I wanted to provide an overview of the breakout session for metering. And anyway, we had participants from the U.S., Japan, Scandinavia, European Commission, and Germany. And here, over the next few slides, I will just give a brief overview of the results of that breakout session. In the U.S., as many of you know, we have the NIST standard based off Handbook 44, which requires a 1.5% accuracy. But in this very early adoption period, California has made an exception and developed a tier approach where they looked at basically relaxing the standard for the near-term deployment. For example, we have accuracy classes that range from 10.0 to 5.0, 3.0, and 2.0. And as you go down into the lower accuracy classes, the accepted tolerance gets tighter, and as well as the maintenance requirements. The 10.0 accuracy class is set to expire at the end of 2017, and the accuracy 3.0 and 5.0 accuracy class is set to expire at the end of 2019. Germany gave an overview of their current data collection effort through the Clean Energy Partnership, where they showed several sets of data where they looked at comparing the station data versus actual vehicle data. And in the graph that's shown here, we see that based on three different OEMs, that the accuracy classes actually, or the accuracy or the measured at the station is very good. In total, through this Clean Energy Partnership, more than 2,000 field data points have been collected. And as you see, you can see 11% of the refuelings have a deviation below 2%. 44% of the refuelings have a deviation below 5%, and 20% of all refuelings have a deviation above 10%. Currently, Germany and Japan have no requirements. In Japan, they're looking to develop a self-guideline in fiscal year 2015, which will be starting April 1st. And then from there, they will develop hopefully by 2019 a Japanese measurement instrument through the Japanese Measurement Instrument Federation, another self-standard, and move to JIS by somewhere between 2023 and 2025. And then finally, not listed here, I just wanted to mention a little bit about the JRC effort. They presented a pre-normative research effort, some initial data collection through some of their fast fueling efforts, and that was presented by Pietro Moretto from the JRC. So if we go to the next slide, to kind of summarize our findings from the breakout session, we broke it down into 3 categories, looking at the definition of meter and accuracy, research and development needs to measure flow, and some international cooperation opportunities. So just to highlight a few from each category, we felt that there could be a need to standardize fueling procedures, or keep standardized fueling procedures at least for the near term. Understand the decrease in hydrogen loss after fueling through nozzle development, and repeatability and accuracy should be improved for meters. Going down to the research and development area, we would like to see 100% of public funded R&D, basically a round-robin competition for the various meter suppliers. And then going into international cooperation, there could be an opportunity to either standardize or harmonize the requirements between the NIST Handbook 44 and an international organization called International Organization of Legal Metrology. They have the R139 standard. And then possibly arrange a workshop for all weights and measures people. And then, as I mentioned, in the R&D area, but also under the international cooperation, the international round-robin R&D flow meters came up. There was mention of one possible landing spot for this is through the International Partnership for Hydrogen Fuel Cells in the Economy Regulation Codes and Standards Working Group. And then more on the regional level, possibly organize regional workshops for that. So with that completes my overview on metering.
All right, thank you, Will. We seem to be having some trouble with the audio from Andres, and it appears to be on our side. Have
Hello?
you been able to... Oh,
can you hear me now?
Yes, we can.
Okay,
Apologize
perfect.
for that.
Okay, thank you. Hello, everybody, and sorry for this disturbance. So I'm going to give you an update about the hydrogen quality activities we had. I'm working for Air Liquide in Germany, and I also lead the hydrogen quality working group at the CEP, at the Clean Energy Partnership. So let me start with one thing that probably you all know, but hydrogen quality for fuel cell vehicles is defined in the ISO document 14687-2, and which is harmonized on the SIE side on the 2719. I think that's even has been standardized for some time. I think that's an important message for the industry, having a harmonized standard already when we are addressing commercialization short term, even if the standard is a controversial one, as there are some discussions, of course, about this being a bit stringent from the gas side and necessarily from the OEM side. But I think it's important to have one document we are working all together towards the future. So during the workshop, we exchanged the status on the different countries, and we came up with a couple of topics that we need to work on. And as a summary, let me summarize those in two subjects. So the technical feasibility of this standard, which is and the commercial feasibility of the standard. So with regard to the technical feasibility, it was mostly agreed by most of the countries that even though we have some methods to analyze the impurities that we need to, they are very costly and time-consuming, and some of them only doable at a very high-quality lab site. So that's really not what we need for commercialization, so we need to work on that, and that was the common understanding of most of the countries present. So we need to work on the reliability of the analysis, mostly with regard to repeatability. So it's nice to have an analysis possibilities, but we need to be able to reproduce them. So, and it is the general opinion that we need to work on that. And good news are, however, that there is a common agreement that we'll probably not need to address all the impurities at all fuel sources. So meaning we don't need to test the same components when we have water electrolysis as a production of hydrogen as when we have steam reforming, for example. So with regard to commercial feasibility of these standards, so is a common understanding, I think, for some time already, and I think we all know that the analytical cost and this kind of standard could be a showstopper for commercialization. So we need to work on a couple of subjects to avoid that. And long-term, mid-term, there are some activities eventually starting at ISO to review the standard. We'll see whether it could be relaxed or it needs to be kept like that. So that's a discussion that will follow at ISO. And short-term, we have some activities with regard to the methodology that we need to apply for quality assurance. This could be the key enabler for reducing the cost short-term and moving towards commercialization. So for that, there's an activity already going on at ISO 2, and where most of the countries represented in this workshop are participating. So then we need also to work on the sampling methods, the containers, and the frequency mostly, which is a bit different from country to country, or it is even not fixed yet in some of the countries, like for example in Germany. So we are doing that on demand, for example, on our side. And this is also a key subject for the cost reduction of the hydrogen quality assurance. So this is the summary of the discussions. Now we got together on, if you go to the next slide, please. We got together on after all the presentations to summarize a bit what are the top challenges and what are the activities that we need to tackle to address these challenges. So we identified the top 4 for this presentation today, which is the top one understanding for the group is the lack of inline monitoring capabilities. So right now we don't have that on the quality we need, on the quality we need to address the ISO standard. So we need to develop an affordable continuous on-site or inline measurement capabilities. Now, independently of the controversial discussion whether this needs to be addressed at the station itself or at the production side, but we'll need some inline analysis for these components. So the top 2 was actually the cost reduction for the analytical methods or for the analysis itself. So one of the subjects we want to tackle, and I think that's being done at ISO in the activity I just mentioned, is to reduce the number of chemical species that you need to analyze depending on the source that you are using. And also, of course, to develop some methods to do so and that not so costly as it is today. On the top three, we identified that as a challenge the standardization of sampling. So for that, we target, or we wanted to have a joint initiative between the ASTM and ISO. So having these two organizations, for example, working together on the standardization of the sampling and sampling equipment and procedures. This could be one of the subjects that could help us on that, or for example, adopt the ISO standards globally, if possible. So there's a couple of other activities that we can tackle on that subject. As a top four, we identified the station quality control subject, which could be a challenge. So we need to identify very short term the critical parameters to monitor online, whether at the source or at the station, and address these. So on that, of course, we need to also harmonize our efforts for the development of best practices and quality control. And that was the common understanding also of the group, really need to be done at ISO, where most of the participants and the relevant countries are working together. So these are the top four challenges and the activities related to it. I think you have a couple of more on the full report if needed. So that would be from my side.
Thank you, Andres.
You're welcome.
Next, presenting hardware will be Bjorn Halvorsen from HIOP Norway. He is the Chief Technology Officer there at HIOP. Bjorn?
Yes, thank you. You're hearing me?
Yes, thank you.
Good. My name is Bjorn Gregert Halvorsen, as you said. I did a presentation on behalf of Scandinavia in Torrance last May on the issue hydrogen station hardware. The conclusion in many ways from the hardware is quite common for all parts. As Japanese, the Europeans, and the Americans, we have a lot in common, and that kind of conclusion is here shown on these two diagrams. Firstly, I think that all concluded on that compressors is a big challenge. The compressors are not as reliable as we would like, and secondly, this influences the total availability of the stations, which is I think we all also concluded on, is not good enough for a real commercial situation. A lot of availability data was communicated, and it showed availability of from, I don't know, 60 to 95, 98%. And the compressors are the main issue, both when it comes to cost and when it comes to time for maintenance, and also when it comes to availability. I think, yeah, I think we jump to the next page. A lot of text here. It is, yeah, the question on maintenance and equipment is what is actually responsible for failures, and compressors is one of the main issues. When we look at this long list, it was a kind of a challenge in Torrance that, you know, we who met there, we are not the manufacturers of equipment. We are the one that use the equipment. We put equipment together as a system supplier, or we just use the hydrogen station. So a lot of these issues that were taken up here is related to the manufacture or the development of equipment. And if we briefly look at the list, if you look at the compressors, I think compressors, they are seen upon as too costly and not robust enough. When it comes to gaseous storage, I think price, it's costly. Price, it's one issue, and another issue is lifetime. What can be done to measure the lifetime or say something about that? When it comes to dispensers, I think again, price of a few very special items that there are very few suppliers of is a challenge. And the other thing is the use for customers. A lot of people don't find it easy enough to handle the thing, and the user friendliness of the hardware is seen upon as a challenge. When it comes to the cooling part of the station, the chiller part, it seems like energy consumption is a concern, and of course the chiller itself could be a quite challenging part to have a good availability on also. Yes, I think that's what I planned to say. Thank you.
Thank you very much. So then just to wrap up here, the report from the workshop has all of the priorities and needs mentioned here, as well as additional priorities and needs identified. While this was not an IPHE meeting, we do plan to work with IPHE to host the report on their website, and it should be available there shortly. We, the participating regions, are already working independently and in collaboration to address the common challenges that we've identified here. We also continue to collaborate on these priorities, and we're in the process of planning our next information exchange to monitor the status, share lessons learned, and identify the key areas for further development. I'd really like to thank everyone who presented today for taking the time to do so. I know it is both early and late for many of you, and I'd like to remind you to our participants to go ahead and submit your questions now, and please identify who your question is for, if possible. Thank you. So with that, going to questions and answers. It looks like the first question is for Mr. Schneider. The question is, will vehicles with greater than 10 kilograms of storage be able to fill at car dispensers? Jesse?
Yes. I should mention that the SAE standards, the J2601, is actually a family of standards. In fact, the first one that's published is the light-duty vehicle. So there is a heavy-duty vehicle a standard that's in the works. It's called J2601-2, which enables fueling above 10 kilograms for buses. It's currently a technical report or a guideline. So for light-duty vehicles, though, there is a limit in terms of fueling, but for buses and greater than 10 kilograms, there's another document coming.
Thank you. The next question is about the targets. It's not directed to a specific person.
Yeah, the question was, most of the stated targets seem much too optimistic, both in terms of the number of vehicles and the number of stations. Is this achievable, is the question. And I don't know if we have at least one OEM. If Jesse, again, would like to take a stab at that in terms of the number of vehicles or the target.
Are you referring? I'm sorry, maybe I didn't hear it acoustically. Are you referring to number of vehicles from the ZEB mandate, or are you talking which one? It
was just a general question. So unless the participant who requested the question can submit a clarification, it was more general about the number of vehicles and the number of stations. Are they too optimistic?
Oh, I see. Well, I think that I could just comment that on the station side, all the regions seem to be working on 50 stations or so in the near term by 2017, and in terms of towards 2020, there's supposed to be about 100 in California. There's supposed to be about to 2023 about 400 in Germany, 450, and there is over 100 stations in the works in Japan. Regarding vehicles, it's hard for me. I can't speak for the competitors and all, but I know that you've heard that the Toyota Prius Toyota Mirai, is already in production. They talked about numbers of 3,000 a year, and there is a projection. There's actually a report from a Northeast region that's being coordinated also and supported by the DOE. That has projections of fuel cell vehicles out to 2025, and I think that's a better reference to quote than one automaker.
Thank you, Jesse. And I think I'll pause to see if any of the other government reps would like to respond as well. But I think in general, as we get feedback from industry on the rollout for vehicles, there are various assessments and analysis on the number of stations that would be required through collaborations. Of course, there is significant state activity, for example, in the U.S. with California, now some of the Northeast states. There's additional activity in Hawaii, and so there's an ongoing assessment of the number of stations needed to support the number of vehicles that would be rolled out. So, and of course, those get refined over time. So I think more of a general comment. It's not that there's a specific target. It changes depending on the number of vehicles and the status of the technology and so forth. So I think that was sort of a general response. We'll go to the next question now, which relates to electric. Yeah, has there been a sensitivity analysis that's been performed which compares the cost of hydrogen storage at different pressures?
And this is Erica Sutherland. I can start taking that question. So one, for clarification, I'm not sure if the question's asking about onboard storage pressures, forecourt storage pressures, or delivery pressures. But I'm going to guess that it's about onboard storage pressures. There is some cost analysis looking at different storage pressures. It is a different answer if you're trying to reduce the cost on board the vehicle and the amount of hydrogen stored for the range versus if you're looking at the cost at the fueling station. There will be a detailed presentation on this at the annual merit review, which will be the week of June 8th in Arlington, Virginia. And those presentations are posted online following the meeting. The presentation will be given by Dr. Amgad Elgoani of Argonne National Lab, and you can look for those results then.
But I think in general, obviously the industry is set to move forth with 700 bar onboard hydrogen storage for the early market rollout. And of course, at DOE, anyway, we do continue our work on low pressure materials-based hydrogen storage. So there's a two-pronged approach, both high pressure storage tanks, and then if the question is also referring to very low pressure options with materials-based storage, That R&D, of course, is still in an early stage of development that continues for potential long-term options to reduce pressure. So we'll go to the next question.
So the next question is to Andreas on fuel quality. And the question is a clarification question about the fuel quality standard. It's the understanding that at what stages are the constituents required to be analyzed. It was said that normally in most situations in the standard it's usually at commissioning, and then depending on the local requirements, either in the case of a dispute or whatever the local requirements are. So can you please clarify, and whether all the constituents have to be analyzed?
Yes, hello. Right now the situation is that the ISO standard only defines the constituents that are needed to be checked and what level of constituents we need to not damage the fuel cell. So in fact, there is no statement right now about how whether you need to analyze them all, but that's exactly what we are trying to do now at the ISO level, is to say, okay, perhaps we can try to reduce the cost and the effort needed for guaranteeing the quality by doing quality assurance in a way that we can say, depending on the source, for example, we don't need to really demonstrate that all the constituents are at the level of the ISO standard, but we can already not do some of the analysis. For example, if you have water electrolysis, you don't need to do necessarily sulfur or something like that. So that's being discussed right now at ISO. That's the one topic. But right now, at this stage, standardized it is not. It is intended to be included in the new ISO standard with regard to hydrogen infrastructure. I think the number, if I remember right, is 19880. So there will be a section of it. So that's the idea. And mid long term, eventually, depending on the field and data we gather, we might tackle the revision of the standard itself. But that's still an open question to what level, whether the industry wants to do it, and to what extent. So that's the one question. The other question is, if I understood right, when do you need to do the analysis and how often, right?
Yes, that's correct.
So right now, that depends a lot on the country. For example, in Germany, I can tell you there is no really regulatory requirement to do any of this. We are right now under a demonstration project, if you want to call it like that, and there is no regulatory requirement for that. So, for example, we do it typically. All the partners in the CEP, we do a sample after commissioning or during before we do commissioning. So before we refill the first vehicles, but this is not an obligation. And then after, and the same for afterwards. So during operation, we do it as needed on demand. So we have done a couple of campaigns in the CEP on testing some of our stations, but that has not been linked to a regulatory requirement. In other countries, it's different, so that differs really regionally a lot still.
Thank you. We have another question which is directed toward our colleagues in Germany. Are there any national programs in place to subsidize fuel cell vehicles?
So I'm going to take that, and this is Arno Butsch from NW. And so far, no, there are no direct subsidy systems in Germany in place. The only thing we have had so far is a business car tax exemption for battery electric mobility, but it didn't include it yet fuel cell cars. But this is under discussion as well.
Thank you. The next question we have is, there was a question, is there a standard in place for hydrogen fueling stations? And I'm going to direct this toward our Safety Kits and Standards lead here, Will James.
So right now, from the international arena, we're in the process of developing an international ISO standard. It's going to be 19880, the 19880 standard. Actually, Jesse Snyder is co-leading that with the European contingent out of France. So maybe if Jesse wants to say a little bit more about the international standard on stations. as well.
Yes, thank you, Will. Can you hear me?
Yes.
Yes.
Okay. Okay, great. Well, exactly what Will said. There is a standardization effort underway internationally called 1980-1, and it covers the fueling station general specification regarding safety. It also covers interface, including fueling and fueling validation. And it covers also safety concepts like safety distances. And at this point, there's also discussions regarding risk assessments. And at the end, the document is going to be published as a guideline at TR this year. And it will be published as a standard at the end of 2016 in order to meet the timing internationally, including for the Alternative Fuels Directive, the AFI.
Thank you, Jesse. Also, there was a question about additional information and additional contact information. The report, as I said, will be hosted by IPHE on their website, so it'll be publicly available from the workshop, and that will hold additional information. And if there's a question that we do not get to in this Q&A, please go ahead and send an email to the organizers, which you will have from the registration email you received, and we will do our best to address all of your questions. We have just a few more minutes here, so I will take one or two last questions. There is a question about current cooperation with Polish companies, and it says it's currently one of the leading countries in the region of Europe. So, is there any collaboration with Poland currently? Perhaps Hanno could help with that one.
Yes, I obviously cannot talk about industrial corporations with Poland, but in the AFI, in the Alternative Fuels Infrastructure Directive, it's clearly stated in Article 5 that there should be a cooperation with neighboring countries. And in this course, there is the so far informal government support group, which is open for all countries to join in order to exchange their experiences and their strategies on the development of the national policy frameworks. And in this course, we try to collaborate with Poland, but current status is they are not yet involved, but we're working on that.
Thank you.
And I think Jesse was also going to comment.
There's one more comment from Jesse on vehicles and stations.
Yes, sorry, I have coffee in hand now to address the question from before. No, I think it's important to mention with regards to the different regions that there are, on the automaker side, 8 automakers have made announcements and partnerships to get hydrogen fuel cell vehicles on the road in commercial light. Some of them in the near term, 2015 all the way up to 2020. So I think that should be mentioned with regards to the supply versus demand question on infrastructure. It also should be mentioned that there was a study by the California Air Resources Board on every automaker directly on what their projections are and also what their commitments are to fuel cell vehicle production. And the result of that was the roadmap for the hydrogen fueling infrastructure to the 100 stations in California. So I think that there is a supply and demand discussion, and there is a need perhaps to redress this when more and more of the fuel cell vehicles are on the road for production.
Thank you very much, Jesse. All right. Unfortunately, we are out of time. As I said, you can send additional questions to the organizers, and we will do our best to address them. I'd like to thank everyone once again for participating today. I know it's a real challenge across all the different time zones, and thank you again to our collaborators in this work. It's really key time moving forward with the infrastructure rolling out and the vehicles coming off the assembly line. So thank you all for your efforts and continued collaboration.
Thank you.
Thank you as well. Goodbye.
Bye-bye.
Thank you very much. Bye.
Bye.